everyone. Today we are super excited to have our wonderful author, Professor Tronvik, for our video interview, Editor's Choice article. And we're going to talk about research and artificial intelligence, AI, and headache. So please, Dr. Professor Tronvik, can you please tell us a little bit about yourself and about your research?
Well, thank you, Nina, for this kind opportunity to participate on this editor choice interview. I'm a neurologist at the St. Olav's University Hospital in Trondheim in Norway, where I have worked with headache patients clinically for more than 20 years. I'm also a full tenured professor at the Norwegian University of Science and Technology, and also the scientific director of NORHED, which is the Norwegian Center for Headache Research.
This is fantastic. Thank you so much for joining us today. And can you please tell us a little bit about the background of your paper?
Well, this paper actually emerged as the result of a talk with a former editor-in-chief of Cephalalgia, Professor Erling Tronvik, where the discussion point was what drives the success and the visibility and also the impact of scientific papers. So, traditional measures of research performance in general, that can be citation counts, AHI index, and impact factors. And what this study set out to do was to use advanced machine learning models, which is a subgroup of artificial intelligence, to predict both the academic impact of headache research papers. That could be like factors to decide how often a study is cited, to what decides more practical importance. And that could be how often a paper is included in medical guidelines or policies.
That's excellent. Why, in your own words, AI and machine learning becoming more important nowadays?
Well, machine learning and AI can handle large amounts of information, and it can also identify patterns that are not necessarily identifiable by the single researcher. So, and for this paper, I think that this type of study, it can be relevant for several stakeholders, both researchers, editors, and funders. So, for researchers, it can be quite hard to tell which studies will have a big impact and to what degree the work will be used academically or how it will influence decisions in a real-world setting. And also for the editors, they have to decide whether to accept or reject papers, and they have limited tools to predict the future influence. And of course, they want to secure a high impact factor for the journal. And funders, organizations that give money for research, they could benefit from a better understanding on how scientific papers influence, for example, treatment guidelines, and how much it can help to solve real-world problems. And AI is a novel tool to look at all this publication information at the same time and try to identify these predictors.
That's excellent. How this research was done by you? What was the methodology?
Well, in this study, all papers from the 3 headache journals, that is Headache, Cephalalgia, and the Journal of Headache and Pain, they were included. So a total of about 8,600 papers with complete data were collected out of a search for approximately 14,000 papers. But we have one limitation, and that was papers that was published after 2017. They were not included because we wanted to identify 5-year citation counts of all the papers. So then we collected what's called bibliometrical data, and that are details like the number of pages of the paper, the number of references, the author's previous, citation counts, and so on. And then we collected text data, and that was information on the paper's title, abstracts, and keywords. And then we used machine learning to build 2 types of models. So the first was a prediction or a citation prediction model, where we wanted to predict which factors influenced on how many times a paper would be cited within 5 years after publication. And the second model was what we called a translational impact model. And this was to predict which factors would influence whether a paper would be included in medical guidelines or policies or not.
That's outstanding amount of excellent work. How does machine learning work?
Well, once we had collected the data, we split the data set into first a training set, and then a validation set, and then a test set. So when the training set was used to build models, which then was used in the validation set, and the top performing model in the validation set was then tested on a test set that was unseen by the researchers. And then we could use techniques to figure out which factors were most important in making the most accurate predictions. So, for example, the degree to which the number of previous high-ranking publications by either the first or the last author would matter for the citation prediction of this paper.
Wow, that's amazing. What were the conclusions, results?
Well, if we looked at the prediction of the citation counts, we found that the models were quite good at predicting how often a paper would be cited. And factors that increased the likelihood of high citations was actually how long a paper was and how many references it had. So experienced authors with many previous papers and high citation counts also counted into this. And we also saw that reviews were more likely to be cited than shorter editorials, for instance. And interestingly, the models found that bibliometrical data was more predictive of citation counts than the actual content of the paper. And when we looked at the prediction, not for citation count, but for real-world impact, how often it was included in guidelines and so on, we saw that the models were also quite good here, but not as good as for citation counts. And contrary to the predictions on citation counts, we found that both bibliometrical data and the content of the paper were equally important.
That's excellent. And were there any limitations of the study, any barriers there?
Yes, I mean, this was sort of the first study of its kind on headache papers. And the models we trained, we included papers only up to 2017. So they might not predict entirely well for new research trends. For instance, when we looked at what type of words that was most frequently used in high citation publication, words like CGRP rarely appeared, and COVID-19, for instance, didn't appear at all, of course, because all of this happened after 2018. But words like adolescents, triptans, epidemiology, they were frequently used in the high citation papers. And also, we had several papers with incomplete data that were not included, because then we would have to impute a lot of data. And also, we analyzed papers from only 3 journals. So expanding to include more journals could possibly improve the models in the future.
That's amazing. And in the paper, I really loved how there is a promise coming from all of that for better diagnostics and individualized treatment for each our patient with migraine and other headache disorders, which this AI and machine learning can help us. What do you think will be in our nearest future or maybe in the future?
Well, I think that on this topic, I think that um, this type of studies will make us more conscious on what type of information actually is implemented into real-world practice, so that we can understand what type of information sort of reaches treatment guidelines and so on. And in a more general aspect, I do think that AI and machine learning is becoming more and more integrated into both research methodology and also the science part. So I think that this is something that will be more commonly used actually in all aspects of medicine.
That's extremely optimistic and promising, and we hope to see you again with Cephalalgia and have more publications of your amazing research. Thank you so much. And our audience, I'm sure, will enjoy and learn a lot from your article and this interview. Thank you so much.